Okay, and these are the last two. This is 8, A and B. And it's going to be another quadratic, but we're going to have to do a little bit more work on this and maybe use an identity. So we have 2 sine squared of x minus cosine of x minus 1 equals 0. Well, like the last ones, we try to get a quadratic. The only problem is that we've got sines and cosines. Now, the key thing is that we look at our linear term cosine of x, and that's what we're going to try to get everything in terms of cosine of x. Okay? Because we know how to change the sine squared of x and the cosine of x because we have this really fine Pythagorean identity over here. Sine squared of x plus the cosine squared of x equals 1. And if we want to find out what the sine of x is, we just subtract the cosine squared. If we want to find out what the cosine is, we just subtract the sine squared. We want to get this in terms of the cosine because we have a linear term. So I'll write the sine squared in terms of the cosine, so I know that the sine squared of x equals 1 minus the cosine squared of x. So I use this variation on the Pythagorean identities to fix this. So I'll rewrite this as 2 and instead of the sine squared, what I'm going to write is 1 minus the cosine squared of x minus the cosine of x minus 1 equals 0. And now I've got everything in cosine, so it's beginning to look like some of the problems we did previously, maybe in number 7. So I'll multiply out, distribute this 2, because I've got numerical and cosine terms in here. So I've got 2 minus 2 cosine squared of x minus the cosine of x minus 1 equals 0. Then I've got these numerical terms I can simplify. 2 minus 1 is 1, so I end up with negative 2 cosine squared of x minus the cosine of x, and then 2 minus 1 is 1 plus 1 equals 0. Now when we're trying to find the zeros of a function like this, or any function, we can divide through by a negative sign, because we can divide 0 by negative 1, it won't change the value, and it will give us the same zeros, the same solutions. Now if we graph it, it'll look a little bit different, but it'd be kind of flipped if we graph it, but it will still give us the same zeros. So we can divide everything by a negative, so we end up with 2 cosine squared of x plus the cosine of x minus 1 equals 0. And again, these were on the interval. I forgot to write this, 0 to 2 pi. So that's our interval. And then we just factor this. Again, just like it was a 2x squared plus x minus 1 equals 0, just like it was a simple quadratic equation. It's just a quadratic in cosine. So I can get 2 cosine of x and cosine of x. That's how I'm going to get 2 cosine squared of x. Now my signs are going to be different, but the only way I can get 1 is 1 times 1, so I just have to play with the signs, and I want to get a positive, so again this is going to be positive, and this is going to be negative, and check it. It's going to be a positive 2 minus 1 is 1. And then we set each of these equal to 0. 2 cosine of x minus 1 equals 0, or cosine of x plus 1 equals 0. This up just a little bit. So if I subtract 1, 2 cosine of x equals 1, so the cosine of x equals 1/2, or the cosine of x equals negative 1. So again, x equals pi, and where's the cosine equal to 1/2? That's going to be pi over 3, so x equals pi over 3, and cosine is positive in the first and fourth quadrant, so we also have over 3. So those would be your solutions. Okay. And one more. And these are those pesky ones where we have a double angle, so we're going to have 4 solutions. Okay, and we just say, when is the sine of x equal to 3/2? Remember, the sine of 2x equals, the square root of 3 over 2. When is the sine of 2x equal to the square root of 3 over 2? So the sine of what is the square root of 3 over 2? Well, we have two possibilities. 2x can either, now it's positive, so it's going to be in the quadrants 1 and 2. And the square root of 3 over 2 is pi over 3. So 2x equals pi over 3. Now, even though we're on this interval, we're also on the interval again, 0 to 2 pi. This is going to change the period, so we're going to have twice as many roots. So we're going to have to add the 2 and pi. And then we also have the next quadrant, so it's also going to be 2x will equal 2 pi over 3. Because again, the sign is positive in the first and second quadrants. So that's 2 pi over 3 is in the second quadrant. Again, plus a 2 and pi. Now this works out pretty good. I can multiply through by 1/2, both sides by 1/2. That's going to take care of my x, so that's going to give me x equals, and pi over 3 times 1/2 is going to be pi over 6. Plus 1/2 of that will be n pi. So my one root will be pi over 6 when n is 0. When n is 1, x equals pi over 6 plus pi, which would be 6 pi over pi. 6 pi over 6. That's 1 pi. And when I add those, I get pi over 6 plus 6 pi over 6 equals 7 pi over 6. So those are the two roots built off of pi over 3. Now I also have two roots built off of 2 pi over 3, the second quadrant part. So again, I'll multiply by 1/2. And this is just going to give me my x. And then 1/2, that's going to give me 2 pi over 6 plus n pi. But that 2 pi over 6, that's just going to be pi over 3. And then the n pi will be 3 pi over 3. That's just one when n is 1. This is when n is 0. We have this root, which is, so when n is 1, we've got 1 pi or 3 pi over 3, and that's going to be 1 plus 3 is 4 pi over 3. So that's my other root. So these are your four roots. X equals pi over 6, pi over 3, and then 7 pi over 6, and 4 pi over 3. Those are your four roots off of that. So those double angles are kind of, or two angles are kind of tough because we have twice as many roots. Okay, hope that makes sense. And good luck tomorrow.